I'm going to talk about a little bit about BIM and our application for BIM and what we're doing with that. I know that there's a lot of technical experts probably out here in the audience. I'm not a technical expert. So I asked our marketing guy to put together for me one slide related to that. And let me translate this for you. At the very bottom, what that means is if you ask a technical question, you're likely to get a pretty stupid answer. Because I honestly, my role at US Engineering related to technology is to help make decisions. And we use technology in all of our operations in different ways. Today I'm going to talk about not just how we use BIM from a technical standpoint, but then I'm going to go into some other things related to our business management practices that I think have applications for other mechanical contractors and might be of interest to you. A little bit about our company. We're a really old company. As you can see, the picture on the left I think is from just post-World War I. The company actually moved from Germany in the 1850s to the United States, and we've been in Kansas City for well over 100 years. Sometimes when you're a large old company, it kind of feels like a really big cruise ship with a really little rudder at the back, if you can imagine that. It can be really hard to move nimbly. And the way construction is going, we have to be able to move nimble and quickly because things change very, very rapidly. If you take a look a little bit at our business, this is a really good snapshot of who we are. That map of the U.S., if you're not familiar with the U.S., we exist in the center of the country. So our headquarters is in Kansas City. We have an operation in Denver, Colorado, and we have a small operation in Manhattan, Kansas, due to a very large government laboratory project. And then the states that are colored blue are areas where we also do business. We have ongoing projects from coast to coast and opportunities that we look at, but primarily 85% of our business is in the center part of the country, and we found that our ability to leverage what we do well is best when we're close to our customers. We currently have a little over 1,100 employees in our business, split equally pretty much between the Denver and Kansas City offices. You can see the breakdown of 882 in the field and 230 in the office, kind of rough numbers. And our annual revenue is somewhere around 270. I think that translation might be a little off in Australian dollars, but we've been anywhere from 250 million to about 310 million over the last 5 years in US dollars. We self-perform plumbing, piping, and sheet metal on all of our projects. And we have service and construction operations and facility management. So that's kind of the scope of what we do. We also do design build in the US. It's called design build here. I think you refer to it more as design construct. But it isn't as prevalent in the markets that we work in. A small percentage of our work is truly design build in our company. Most commonly our work is what we would determine or call design assist, where we get brought in early to work with a design team, but the design team is separate from us. What I want to do is give you a little bit of background real quickly on the projects we work on, because I think those projects have in large part determined or helped us determine what kind of technology we need to apply. We're a very large company when it comes to healthcare. This project I'm going to show you a clip of here in a little bit was a brand new hospital project in Denver. But we have at any single time in our company at least a half a dozen to a dozen hospital projects going on. And annually we do between $50 and $100 million of just hospital work. So it's a very large part of our business. Sometimes I wonder why so many mechanical contractors want to do hospital projects, because they're so difficult to be successful on. They're the most complex projects above the ceiling. When you're trying to coordinate things, any of you that have been in the BIM world knows that they're very difficult to coordinate. They tend to be driven by a number of doctors that want to make different decisions at different times. There can be 10 different user groups giving you input. Very challenging projects. Sometimes very difficult to be profitable on. Second type of project we do a lot of work on is data centers. And the interesting thing about data centers is that, for one, they're schedule driven. Number two, mechanically, they're usually very easy to coordinate because our systems are very large and there's other systems that are not in the way. We don't have the kind of problems above ceilings in hospitals that we have. But we do data centers for some of the largest technology companies in the world. I can't mention who they all are because we have non-disclosure agreements, but I would tell you those customers are interested in the data behind what you're doing because they want to shorten the time to build their projects dramatically. So they're aggressively trying to find ways to build data centers in half the time that has been done in the past. And that really pushes you to think about things differently. Third type of project where we do lots of work is laboratories. And we do some very complicated laboratory work. We're currently working on a BSL-4 lab that will be the most biosecure lab in the world when it's complete for animal research. And in that lab, they'll bring healthy animals in and they will challenge those animals with some of the worst diseases that animals have in the world, and they'll study how to try to develop vaccines for that. I honestly thought that I had seen the most complicated systems in my career until I saw these projects and started to understand the magnitude of redundancy and precision that have to occur in a facility like that. What's interesting about these kind of projects is that we end up involved very, very early. There's a long design process on these, okay? And so in this particular case, this project I'm talking about, we were involved for 6 years before it started construction. So 6 years of planning on this. Now we're starting construction and it's a 6-year construction cycle. So they're very, very long, but they're very highly technically challenging. And we're also, one other thing I want to talk about our company is we're manufacturing driven. And there's some importance to that in that our technology really has to support a concept that we want to manufacture our projects. We don't want to deliver material to the site and build them on site. There's just way too much volatility on site. And so we want to manufacture everything we can. And I'm going to talk about that in different ways a little bit later in this presentation, but it does affect everything that we look at when we talk about technology. And technology truly is the trigger that allows you to do more manufacturing. So if you're thinking about expanding how much you fabricate in a shop, you have to have the technical support to do it. We have currently in the company about 220,000 square feet of manufacturing space. I'm not good at converting that to square meters. You guys probably are much better at doing that. But we find at times that's not enough, and we actually have leased space regularly for large projects. And so that happens a lot. One other thing that has really helped develop kind of our approach to business, I'm going to give credit to the MCAA, and similar to the AMCA, our organization in the States really provides excellent opportunities for learning. So we have construction technology conferences, fabrication conferences, the annual meeting every year. I would highly encourage you. I know it's a long way to go from Australia to the United States to attend, but if there's one event I would ever tell you to attend, come to the MCAA annual convention and you will be blown away by the quality of education that you will receive. It's truly worthwhile. It's helped shape our company in a lot of different ways. One other thing I want to point out that has helped us dramatically, I'm currently co-chair of the Labor Estimating Committee. Ron, can you raise your hand in the back? That's my co-chair. Ron's with Trimble. He's from Toronto, one of my best friends in the world. Truly, if everybody here probably knows about the MCAE labor units. If you're familiar with the labor units, raise your hand real quick so I get some idea. I will just tell you, if you have any questions at all about labor units, he truly is the single best resource in the whole world on those. So if you ever have questions while you're here, take advantage of Ron because he's the driver behind a lot of that data. But the importance of being involved in that committee has helped me understand the data a lot better. And we use that in a lot of different ways, and it drives kind of our thinking on how we can install work more effectively. Because when you break those labor units down, you start to understand how much time does it take to make a joint, how much time does it take to install the item in the field, how much non-productive time is there in each one of those labor units? And it's the non-productive time that you're really trying to drive out, and it's surprising how big a percent of that number is truly non-productive time. So I want to show you a little bit about some modularization, and this is just one picture. We had this sitting in our shop for a little while so we could try to explain to customers what modularization looks like. I assume this is not uncommon to any of you. We started modularizing projects in 2010, and I don't think that that's unusual in construction, so I want to talk about this for just 1 minute. We've got a short clip on some of the modularization we did in 2010. The project clip I'm about to show you is a project that we built in Denver at University of Colorado Hospital, and it was the second project in the US where modularization on a hospital was done. The first one was done in Florida by Skanska, and a lesson learned on this: if you see something that's new and different going on in the industry, our experience has been if you reach out to the project team to learn something about it, they will share with you what they've done. People are proud of developing new approaches to business, and you just have to take the step to go ask. In this particular case, we called Skanska out of the blue and said, we want to come down and learn what you're doing. We took a trip down to Florida, learned what they're doing, and we came back and applied that on the next job. So this is a clip of that project. And it goes pretty fast. So you can see some of the modeling. And these are corridor sections. And those corridor sections were standardized in 20-foot long lengths because that's the length of a standard section of pipe. You can notice that there's drywall on them. Those are fire-rated walls. And we were able to lift those into place in the hospital rapidly. Now, this is obviously time-lapsed, but we had over 2,000 linear feet of corridor racks that were put in this project. The second thing that we modularized were the head walls. If you've done hospital work, there's a lot of head walls. And we had over 300 head wall units, and we designed ways to lift those into place and get them in the building. And the third thing that we modularized on this were bathrooms. And we actually had questions whether the framers would be happy doing this in our warehouse, and they were hesitant. But when they got done, they absolutely loved it. So I got to give props to Hazelden Construction. That was the general contractor that put the video together. A lot of lessons learned from that project. It was the first one that we did. It's become standard on every hospital project that we modularize things. And they're multi-trade assemblies. They're done in a warehouse, usually near the project site. That technology is rapidly advancing into all forms of projects. So we have a project going right now that's a high-rise hotel. They were talking about modularizing the entire front half of the hotel room. So the bathrooms and the fan coils that are above the ceiling, all of the mechanical components would be contained within that module. And that technology is spreading out. I guess the couple things that I'd like to say related to this is we used to think that to do modularization like that, you needed a repetitive circumstance. And the only way you gained efficiency was by that repetitive circumstance. So think of a bathroom being constructed the same way 200 times or more. One of the things that we found is you don't need repetitive circumstance. What you need is a manufacturing modularization mindset. So as an example, those corridor sections, there weren't two of them alike. But one thing was alike on all of them. They were all 20-foot long, so that a standard section of pipe would stretch out beyond it just a little bit. And the reason they don't need to be repetitive is because you actually, through the technology of the virtual construction and the BIM model, can lay out in detail exactly what has to be done on each section. And you just set up a manufacturing process, and away you go. It's no different than any other manufacturer that has options, whether it's an automobile or anything else that's built that way. Whoops, I didn't want to do that. Let me move on here. So I want to talk now a little bit about how we've gotten to where we are, and so that I can get into some detail of how we're using the BIM models to our advantage. So when I look back at some key moments from our company standpoint. 15 years ago, we developed our own software to do conceptual estimating. If you get involved early in projects, you have to come up with a way to estimate projects. This program's been redone and redone and redone many times, but that was the first piece of intellectual property that we actually created that could have been sold to the market. And it got us thinking that at times we should be developing our own IP. 10 years ago, we got involved with a project with Mortenson in the United States for the Denver Art Museum. Now, I don't know if this is true or not, but Mortenson would tell you they invented 4D BIM. Can't tell you if that's true or not. They claim this was the first project ever that had a 4D model on it. What I can tell you is it's a very challenging building. That's actually a picture of it to the right. There isn't a single piece of the outside structure of that building that's either vertical or horizontal. Not one. Okay, so if you can think about piping and ductwork fitting inside a structure that doesn't have any horizontal or vertical surfaces, it was quite a challenge. It has a titanium skin on it that has leaked badly since they first installed it. So Denver is still dealing with that. But it is a beautiful project, and it got us thinking about how to use the model differently. And I think that's the point of this slide, is the model started to become a more important information source on our projects. It wasn't just how are we going to build the project, but in this case, it was how do each of those pieces go together in some sequential order that makes sense. And when they first applied that 4 dimension to that model, and you could sit in a room with the owner and show them the building being built in the sequence it was going to be built, it was mind-blowing to them that you could do that virtually. Today, that's not unusual at all, right? 4D, 5D, 6D, I can tell you we embed dozens of pieces of metadata into our BIM objects. 6 years ago was that first HospitalClip where we started to modularize projects, and like I said, that's become standard on most projects for us. 3 years ago, we standardized our scheduling software. So we're a large company. We have about 120 project managers, project engineers in our business, and at times it's really hard to keep people all working the same way. We had Primavera schedules, we had Microsoft project schedules, we had Asta Power project schedules, we had all different kinds of things. We started to realize if we were going to leverage data, we had to get standardized. And so we picked internally a new scheduling software. We use Asta Power project across the corporation on all projects. And that helped us start to get more consistent with the data. We also started creating our own original BIM content. And I'm going to get into that in a minute. I'm sure some of you are interested in that. There's a long story behind that, but we decided 3 years ago that the content that was available for us in the market was not fulfilling our needs. And we made a decision at a time without really knowing what we were getting into that we were going to go down the path of creating some of our own content. 2 years ago, we also implemented a SharePoint environment. I don't know if you know much about Microsoft SharePoint. If you don't, I am going to talk about that today because I think our industry is lagging behind a lot of other industries in the use of workflows that can be automated in an environment like SharePoint. And it's some very basic thinking about how you automate workflows. But I would tell you one thing that's absolutely true that everyone I talk to in the construction industry will agree with is that on our job sites, the amount of documentation that our project teams are dealing with is exploding, okay? You have to find a way to manage that so that your people can run the projects, or else they will spend all their time managing documents. And that's really not what you want to do. So to me, this is a key point in how to handle that. Second thing we did 2 years ago is we went on to a new ERP. And this was key to us because we wanted a solution that went all the way from design through service and facility management. And in mechanical construction companies, it's actually common to have separate accounting softwares for service and construction because they have such different demands, and that is really common. We finally found one that we feel like works well for us in all ways. And the third thing that we did, and I'm going to talk a lot about this because I believe it's an underlying foundation for everything we do around capturing data and utilizing it is we went with the WBS coding system. So work breakdown structure, that term has come from the scheduling industry. If you work with schedulers long enough, somebody's going to mention WBS, that acronym. Okay, we historically have called our accounting breakdown cost codes. I'm not sure what the normal Australian contractor would call that, but whatever you break your job down into your accounting system is what this is. And the importance of the work breakdown structure can't be understated, so I will talk about that a little bit more. But that's kind of the things that led us up to where we're at. Now, a little bit I wanted to do is talk about IT spending by industry. This is a very interesting piece of data when you look at it. Across all industries, look where construction ranks. At the very bottom of this list at 1%. I mean, that, to me, is indicative of where our industry is, and obviously, I don't think this is where we want to be long-term, and that our investment in technology is the lowest. We've worked really hard at trying to understand where we are at as a company. And what we found is we think we're at about 1.5% of total revenue in IT spending. I put this up here because it's taken us over a year just to figure out how much are we really spending on it. Okay, because you have these disaggregated purchases going on projects. You find out people are buying big screen monitors for the job site, and they're replacing phones, and all of a sudden they got different kinds of computers, and they contacted your technology staff to try to get a computer. They couldn't get it fast enough. They went down to the store and bought one on their own, so it's different than everything else in your company. And this is going on all over the place. And I would tell you one step, if you want to manage your IT and technology, you have to get it all organized in a bucket that you can understand what you're spending first. And it's taken us a long time not only to get it organized, but to then get it coded in a way that we can understand it, so we know what we're spending, we understand exactly where we can try to save some money. And here's one of the things that we've understood. We spend about 33% on staff, so those are in-house peoples or they are consultants. 21% on infrastructure, which would be network and internet connections and things like that. About 20% on hardware. Hardware would include phones, so our cell phones and so forth are in this as well. And 26% on capital expenses. Capital expenses for us would be a large purchase, something bigger than $5,000 that by our tax code in the US I can capitalize and depreciate. So if we're making a $100,000 investment in a piece of software, it would go under a capital expense. This is what our IT technology structure looks like. So keep in mind we have about 1,100 employees. We have about 275 computers out in the hands of employees, and we have about 550 user accounts. So we have a number of people that don't actually have a computer, but they have a phone and they've got an email address and a user account. We currently have 9 people full-time that are working on infrastructure and support. And we have 5 that are full-time on application specialists. And those 5 are working to try to develop applications that drive our operations. So one of the things that we do when we talk about IT and IT spending in our company is we demand that our investments in IT have some kind of cost-benefit analysis before we make those expenses. Sometimes that's really hard to get your hands around. Am I going to get a return on this investment if I go spend $50,000 or $100,000 or $1 million on a technology investment? Is it going to pay back? And we spend the time to try to understand, is it going to pay back before I make that investment? I can tell you that 5 years ago, this would have looked like 2 people on the left and 1 person on the right. So when you talk about how fast things change, that's how fast things change. Okay, so that's kind of enough background on what's gotten us to where we are. What I want to do now is talk a little bit about BIM models and what we are doing with our BIM models. I mentioned a little bit ago that we started getting into the creation of BIM content 3 years ago. this is what we thought we were getting into. We thought that we could have one person for 6 months involved in this, and we could create the content we needed. So the example of that would be, well, gosh, we really only need carbon steel welded information because we do a lot of carbon steel welded projects, and we need copper. So if we create those, that'll be enough. And the focus, the reason we were doing this is we really thought that we could streamline the process better. If we had content that was specific to the manufacturer we were buying, we could get dimensionally accurate information in the model. We could take that information straight from the model to our cutters for the pipe and the sheet metal directly to it with complete confidence that we're going to get cut lengths exactly right. If you don't have that, you're someone in your shop. What happens in most mechanical contractors in the US, and I can't speak for any of you here, but in the US, probably 9 out of 10 mechanical contractors get the model to their fabrication shop, and the fabrication shop foreman has the model, and he's got the spools of the pipe. Let's just use pipe for an example. And he gets the cut sheet for the valves that they're actually buying on that job, and with a pencil on the piece of paper, he figures out what that cut length needs to be. And then he goes to the cutter and he measures it, marks it, and cuts it. That's 9 out of 10 contractors in the US, because they haven't solved the issue of manufacturer-specific content to get it dimensionally accurate. And they haven't been able to get the technology directly connected to their cutters, whether it's sheet metal or piping. What we found once we got into this was just what you're kind of afraid of if you're looking at it. We went down this path and determined that, gosh, well, it turned into a lot more than one person for 6 months. And if you had asked me back then, would I make that investment if knowing that this is what it was going to be? I would have told you no until about 6 months ago, honestly, because we had 3 people working on this for now 2 to 3 years. And frankly, if you're getting into the development of content with the idea that it's going to streamline how you get to fabrication, that's not enough. The effort is way too much, and the gain is way too little. You have to find a way for that effort to relate directly to your productivity and the management of productivity on projects, because that's where the big gain is. Okay, so we talk about 27 fields of metadata, all kinds of data that we embed in each object when we build these. When we build them out, we build out the whole catalog of the manufacturer, because next week we might have a project where we needed a different size or a different valve or whatever, and while we've got that information, we just build it out. Our guys start going and they build it out. We started to shift to how to use this from a productivity standpoint. Now I'm going to do a little bit of a deep dive into the BIM itself and show you some of the granular information. This is where this goes way beyond me technically, but I had our guys pull this together so you can see it if there's some BIM people here. This is just an example of our library, and you can see by manufacturer. I think I'm drilled down into Nibco copper soldered, wrought copper soldered fittings, and we embed everything from a high definition picture of the item in as well as information about the items. And the reason we do that is so that when our BIM operators are actually doing the work, they can see what it is they're picking. It's extremely helpful and faster if the operator can actually see a real picture of what he's putting in the model when we go about doing that. If I take a look at the model, so in this particular case, this happens to be one of those copper fittings. You can see I'm kind of driving my mouse around it. If you were to highlight that and click on it, up comes a screen with some information. The 2 pieces of information I want to point out that are in here is here's the labor dollars to install that item, and here's the material cost for that item. So we have material cost and labor dollars inserted there. Let's talk about that for just 1 minute. The material cost is actually list price, so we use a pricing service. In the US, we get, when we bid a project, we're going to get a discount from the manufacturer on that list price. So this is a full list price that's in here. We would get a discount and apply that to that number to get the actual bid day price. The labor that's in here, we have, the way our system is set up, you define a labor rate it could be $60 or $65 an hour in the US, all in with benefits. And this $10.56 per hour is related directly to the MCAA labor units. So we have the MCAA labor units embedded into our objects. The third thing I wanted to show in terms of what we're doing is we're actually controlling the status of the items. So up here, you can see this status. If you can read that, it says installed. So what we started to realize with our models is that if we could update the status of objects, so let's talk about status. It could be it's been designed, it's been spooled, it's been fabricated, it's been delivered to the site, it's been installed, it's been commissioned, okay? If I had that updated any single time, I'd really know where we were at on our project. So we decided we really needed the status of the objects. And the last thing we needed was we needed the WBS input. So we have down here, it's kind of hard to see, but there are 6 fields down here that relate to our work breakdown structure because we want to be able to know how do I break out and account for the status of those objects compared to payroll information. And then when you have all that kind of information, it becomes quite easy to run reports. This just happens to be an example of a cost report that comes right out of the model. From the model, you can get all kinds of reports. You can get reports that go straight to your suppliers for procurement without touching it. So we can highlight an area on the model, run a bill of materials report, and literally, without even looking at it, send that off to our suppliers, and they can read exactly what it is that's in that model by their brand name. Okay, so one other piece of advice, if you get into any kind of creating content, you really have to think about what you're going to use that information for, because when we first started doing this, we were using more generic names for the items. And what would happen is we would run a report and we would say, okay, we want to send that to our suppliers to get price quotes on it. And they weren't sure what it is we were asking them to bid. Okay, because each manufacturer has some kind of different language that they use. They've got a catalog name or a model number or something. So if you're going to go to the point of building content at any time, make sure you think about the end purpose use of that, because we had to go back and rename a number of things. All right, now I want to step back for just 1 minute and talk about the work breakdown structure. So this is what our work breakdown structure looks like. I would tell you this is the culmination of an effort that took us over a year to try to figure out. So our company, as I mentioned, been around for over 100 years. We have some people that have been around for, actually we have employees been with us for more than 50. But we have a lot of people that are opinionated on how our work ought to be broken down in terms of the accounting system. And we decided that we needed a common platform for gathering data across the whole organization. If we don't have that, we can't aggregate the data. So here, this is what we do. And I'm just going to give you examples of each one here so you can kind of understand how we're using a work breakdown structure. So building 1, floor 1 would be obvious for level 1. An area could be area 1 or a mechanical room or radiology, for example. Sometimes these area breakdowns are driven by what the general contractor and the owner want us to do when it comes to billing the projects. So when we build a project, sometimes they want to know, how much are you billing me for the radiology department in this particular pay application? And then we have what we call discipline. So discipline would be the trade. Is it a plumber? Is it a pipe fitter? Are they in our fab shop or are they in the field? That's pretty straightforward. Skill is actually what kind of crew is it that's doing the work, because in the US we might have different people out there if it's carbon steel welded pipe or if it's copper pipe. Even though those are both pipe fitters doing the work, we might have different people there. So this comes back to kind of a scheduling philosophy where when you resource load things, you might have different teams doing the work, and so you need to think through that. And then at the very bottom of the work breakdown structure is cost category, which gets to very specific, like where is that piece of pipe? Is it above the ceiling? Is it connecting to a piece of equipment? Is it at a terminal unit? What is it? So these all have a common code. Here's an example of that code. So that code would, on our ERP, it would look like that. I say that because here's the challenge that we are all faced with, right? And this kind of would be the natural chronology on a job. You estimate a project, you win it, it goes into your accounting software, you start to model it, and then you start to schedule it. Those all happen at different times on the project. And I can tell you until 2 years ago, these were all different breakdowns in our company. And I imagine they are for most people out there in the audience, right? It's real common to estimate a job the fastest way to estimate it with the least amount of breakdown, because you estimate 4 jobs, you only win 1. And you don't want to do that. And so then once you win it, it's a mad race to start building it. So do you have the time to go back and get it in the breakdown that your project manager wants? Probably not entirely. Your accounting software is a cost code system that could have been around for decades. In our case, it was. We had 1,200 cost codes. It was way too much. The other thing I've learned about data is that more detail doesn't mean more accurate. It definitely means less accurate a lot of times. If you get beyond the point where it's too much detail, it will absolutely not be accurate. Okay, so we've actually cut that all the way down. Right now, the complete number of combinations in our work breakdown structure, if I disregard building and area, we have about 300 combinations that could possibly apply to any project in our whole company. And then you have BIM software, and I would tell you in the BIM software, very few people are coding the items at all. They don't get the code. There's a real problem with that, though. I can't gather data from it if I don't code it. And then the third thing is scheduling software, and one of the challenges mechanical contractors have is that we don't all, in our industry in the US, and I don't know about here, but very few mechanical contractors actually have a scheduling resource in their business. They outsource it a lot to a consultant. They get people to do it part-time. The problem with that is it doesn't have consistency. So we took all 4 of those and said, we're going to create one structure. And at the end of the day, we've achieved something that I think is absolutely critical if you want to gather data and use it. You have to have everything overlying that one data structure, or you can't capture the information and align it. If you expect your people to capture disaggregated information and line it all up on their own, I'll just tell you it doesn't happen because they're too busy doing other things. So that's the first step I would tell you if you want to gather data and use it. Okay, now I'm going to look at a project here, an example of how we use this data. This happens to be a university football stadium. Football can mean a lot of things in different parts of the world. In this case, it's American football. But this project is an addition onto the end of that building. It happens to be this piece right here. And I'm going to talk just a little bit about a very simple example where we're able to use that information from the model to our advantage. This example is just a small example. It's piping installed in one floor in one area of this building. And that piping is largely not fabricated because there are complications that come with splitting things between fabrication and field. But I want to show you what the information is that we collect. So this is an example over 6 weeks of time. In gray is the estimated hours for this example. And in blue is what the actual were for doing that same work. So you can kind of see the way this thing started off. Didn't start off so hot. We didn't meet our hours to begin with. In the second measurement, we got a little bit closer. In the third measurement, we beat it. And in the fourth measurement, when you're doing odds and ends, this is closing out a little bit of a project. Is if you ever measure what happens at the very end of a project and you're doing a little bit of work here and a little bit of work there, your productivity usually goes pretty poorly. Down below this, you see the actual MCA factor. So I think we bid this project at a factor of 0.85, and you can see how we perform down here. Now, how do we gather that information? Well, this is a picture of the model. This is before we started gathering the data. And you'll notice everything on the model is yellow, which means that it's been designed. Okay, that's the status of everything in the model, and you can see over here on the right the timeline where we are. We go to the next stage, and what happens in our company is every week to 2 weeks, people go out and they mark the model up and they change the status of objects. So the status changes from yellow to blue. That means now it's installed. And when you change that status from yellow to blue, and that's installed, that same week, our workers are inputting time cards. So our payroll comes in every Friday. Everything comes in per the work breakdown structure. It goes into the system by Tuesday at noon, and by Tuesday afternoon, every single project in the company has updated payroll information from the week before. So if you can imagine now, what I've got is I've got actual hours by the work breakdown structure, and I've got status of objects installed from the model, and I can do a comparison, and that's how that blue line is determined. So it's earned hours. It's not just actual hours, it's earned hours. It's how much have I earned. So this is what's really interesting, is when we get that first measurement on jobs and we're not meeting our estimate, if something doesn't happen, from my experience, it's going to continue to trend exactly what that first point looks like. I've been with our company for 20 years, and in 20 years of sitting through forecast reviews month after month after month after month, there's one thing I can tell you. If you don't like the trend on a job site, you have to do something or it will stay exactly the same. That seems really simple, like it's really obvious. It doesn't, but it's really hard to do. And the other thing that I've learned is that if you want to have any impact, you have to do it really early. And in fact, a lot of the processes we have designed are all designed around doing something before 1/3 of the labor is spent, because I believe after 1/3 of the labor is spent, you've got a culture that you can't change unless you change out most everybody on the job. Okay? So the power of this is I have one data point and I know we need to act. I would tell you, until we started having that information from the model, we would never have this at this point in time. We wouldn't have it. So what we would have would be, before we had this from the model, we would have a project manager or even a vice president walking a job site, looking at what's been installed, and making an estimate of % complete on each one of our cost codes. Does that sound familiar to people? Here's what we found. We took our most experienced person and had them walk the first job that we used this data on and said, tell us how much % complete we are. The most experienced guy came back, wrote it down, compared it to what the model said, and he was way off. He thought we were 33% complete. The model said we were 24. He said, no way, I don't believe it. And he was wrong, the model's right. So here's what we've come to learn over that time. It's like, I'll use an analogy here. Jack and I, one thing that we like to do, we like to hike in the mountains of Colorado. And to keep us from getting lost, we use a GPS. And we lay a route out, and we've hiked all over the mountains of Colorado. And many times we get lost from the trail. And I used to say, I know where the trail is, the GPS is wrong. GPS is telling me the trail's to the right. I'm certain it's to the left. I'd start walking to the left. I've never once found the GPS to be wrong. Never. It's always right. We're always wrong. I've also found in this case, this is very objective data. There's no subjectivity to it. It has a tendency to be a little bit unforgiving in that work that's partially complete you don't get a lot of credit for. Okay, so that's one negative to it. However, it takes the subjectivity out of it, and now what I can do is gather the data. And if you think about doing profit forecasts this way on your jobs, I don't actually have to have the most experienced guy out there looking at things trying to figure out how complete I am, right? I could actually have a project engineer just figuring out the status of the model. It isn't a high-level person doing it once the technology is in place. So this is how this progresses. In this particular case, by the way, right after that happens, we had a meeting on site. We changed some people out. We reorganized some sequences. And we managed the material handling differently, and the job started to recover. So it got a little bit better. In the second measurement, it got even better yet. In the third, we actually beat our labor unit. We were at 0.69 versus a bid day number of 0.85. And then it finished down here. Well, here's something that's really interesting. So here's the cumulative earned value versus the estimated. So we didn't quite make it all the way back. But here's what I really want to show you. So when I talked earlier about the idea that until 6 months ago I would have said the investment in the content wasn't worthwhile, this is where it becomes worthwhile. That red line represents what would have happened in my view if we'd not had that information. If I take the trend after the first point and I just run it out, This is exactly what would have happened on that job, and I've watched it happen on job after job after job on other projects. So what does that represent? That's a 14.5% labor reduction. That's meaningful, right? This is a $5.5 million project roughly for us. That represents $360,000 in savings to our company, right to the bottom line. So, you know, when I start looking at this, now I get excited. Okay, this to me is real good information. We can't work hard enough to get this in the hands of our whole industry because it gives you the right kind of tool to manage your labor. The other thing that I would say about it is that people become really motivated when you put the right information in their hands. So when you're dealing with subjective processes, you know, and trying to do labor forecasts and trying to convince people that you have or don't have a problem on a project, and it's not backed up by data, you don't have the same kind of buy-in. I can tell you right now, we have, at this point in our company, about 7 or 8 projects right now that are running what this software approach we call Game Changer. And we have it active on about 7 or 8 projects with the idea that by the end of the calendar year, it'll be on every project. It does take time because when we develop our BIM models, we aren't coding the BIM models at that time, right? Your coordination guys are making everything fit, and then they're spooling it for the fabrication shop. When we get to that point, then somebody goes back and they embed the work breakdown structure in the model. The labor and material exists there all the time. We have written some scripts that allow us to change the work breakdown structure and the status all at one time. So we can draw a window around an area and make that all objects within that window be a certain work breakdown structure, but you have to laboriously go through the whole model and do it. But it's worthwhile. There's no doubt it's worthwhile. Okay, I want to transition now as quickly as I can, because we're running a little bit behind, to our SharePoint environment. And this is a picture of our homepage on our SharePoint environment. What you see here on the top, all these red, yellow, green lights, I was worried when we were coming to Australia that your lights might not even be the same as ours and this wouldn't work, but your lights are the same as ours, so that was helpful. So one other thing that we started thinking about internally a couple years ago is how to better manage exception reports. And let me describe an exception report to you. An exception report is give me a list of all projects that have a receivable that's greater than $500,000 that's more than 60 days old, right? As a business owner, you'd want to know that. So give me that list. And so you're applying a logical test to a large group of projects, and out of it falls this list of problems, if you will. That's the challenge with exception reports. The problem with exception reports is you've already got a problem by the time it reaches the report and you didn't know it. So what we've tried to do is think through, well, how do I, instead of getting exception reports and working on the problems, how do I create a system that reinforces the behavior that we think we need to keep things off of the exception reports? And this is our attempt at doing that, these 10 lights here. I'm actually going to go off the PowerPoint for 1 minute, and I'm going to go live to our website. So this is a project on our website. I'm connected with a VPN into our website right now. And so what these red, yellow, and green lights are what we believe the 10 most important planning processes on a project that have to happen in the first quarter of a job. And to get those lights to turn from green to yellow to red, project manager has to do something. So if I were to pull this up and roll over it, you can see here's a whole list of this is what he's got to do to turn that from green to yellow to red. We're still experimenting with this, but we're starting to see some behaviors change because the guys like to see green lights. Okay, it's quite interesting. This is a very simple philosophy, but they like to see green lights. Don't actually have to do a lot of training if it's actually explained pretty well. The other thing I wanted to do is drill into this report section. If I can bring this up, hopefully my web connection will last. And I'm going to show you a little bit about where data can be aggregated to your benefit. And I actually debated whether or not I would show this because this can be a touchy subject. We're going to show you our over and under billings if this comes up. There we go. I'm not getting all the data. Let me refresh this. So let me talk about this for a minute. For 20 years, I've been talking to our people about don't get underbilled, please get overbilled, please get overbilled. We need cash to run our business. Every contractor knows they need cash to run the business. We have retention in the US, usually around 5% of our contract is withheld. If you don't bill the work that you're doing, we're certainly not going to collect it. Please at least bill how much you're doing, and if we're doing well, bill more than what we're doing. And for 20 years, we have probably 2/3 of our projects billed properly and 1/3 underbilled. We released this dashboard with this big green round circle with an arrow pointing up and green if they're overbilled and red pointing down if they're underbilled. And within 3 months, every single project had a green arrow pointing up with no training. This was an amazing thing, frankly, from my perspective, because I had thought we had done everything we could do to get people to understand the importance of overbillings. But what it really told me was if you give people the right information in a simple to understand format, they'll do something with it, but you got to give it to them. Okay? This is a SharePoint environment that can give you just great information. So we're going to talk about SharePoint. This is pulling directly from our ERP. Now, if you think that we're being unfair by overbilling, if you look here, we're actually negative $1.4 million in cash on the project. Okay, so I can actually have a good discussion with the owner about, yeah, we're overbilled by $600,000, but we're underpaid by $1.4 million, which is well more than our retention on the project. If I come down here, I can also look now at forecast hours, and here's where things get interesting to me. This is where that game changer information comes into a dashboard and displays automatically for our people, so I can actually look at where we stand on earned versus actual work that's being done. This acronym down here is straight from our work breakdown structure. So this is cast iron, that would be plumbing work. This is carbon steel, this is copper, this is galvanized duct, this is industrial or specialty work, this is plastic waste, and this is plastic hydronic pipe. So in a real quick and easy way, our guys can see how am I trending. I can tell you on this project, one of the reasons that we're behind here is that we have a lot of fabrication that hasn't been installed yet, and he hasn't gotten credit for it. Okay? But he knows that because he can look at it. So the point of showing you this is I really believe that you need to get good information in front of your people for them to use it. Now I'm going to go back to the presentation here. And I want to show you a second thing about SharePoint that I think is really important. So this is a workflow. This is another thing that we do with SharePoint. So this is a workflow of an incoming document. I mentioned before that on projects we're getting just bombarded with documentation, right? Everybody's seen this. It comes in. How do you manage the documentation? So here's what our process looked like a year ago. Something comes in, does it have a scope impact or not? This is the first thing your project manager is doing. If it does, you got all these things you've got to do. You might be opening multiple different programs. You might be opening email files and sending files and attaching PDFs and logging them and tracking them. Does that sound common to you guys? Does that happen here quite a bit? Well, with SharePoint, when you automate that, this is what that now looks like. This is a really simple program, a real simple way to automate things that you do in your business. If you don't have a good document management system that's doing this for you, I would highly suggest that you look at it. Microsoft SharePoint in its most basic form is a free software if you're running Microsoft products. So if you have an Exchange network and an Outlook that you're using, you have SharePoint. You probably just don't know it. Now, I will tell you, once you start to use it, you're going to want more advanced features, most probably, and you will pay some money for that software. But if you don't have a good document management system, I highly suggest you look at it, because on this one project, same project I mentioned before, here's the impact of that. That one workflow saves 100 hours to that team. So I talked before about trying to get down to a cost-benefit analysis. And I would tell you, if you hired one person that can program SharePoint, in the US, you can find those people for $40,000, $50,000, $60,000 a year. They will pay for themselves really fast. Because now what you do with that 100 hours is you get your people managing the productivity on the job site instead of managing the documentation. So you might ask, well, how many workflows could we possibly want? Well, here's how many we have in the last year and a half. We have over 50 that we've already automated. And one of the things that we found once we started automating those is that people started coming up with all kinds of new ones that they wanted us to automate. And this just keeps building upon itself as soon as people see how you do that. The other thing that happens in a SharePoint environment is that if I went back to that website that I was in, where I was showing you the financials, you can simply type in a search bar. So let's say I wanted to find everything related to a water heater on a project, type in water heater. It would bring up every document related to that project that has the word water heater in it. Not in the title, in the document. PDFs, Excel, drawings, everything. It'll search it all. They'll all be links. Find the one you want, you click on it, that document's at your fingertips really fast. So it saves your people just inordinate amounts of time. Okay, so I want to conclude with two things. One is some lessons learned, and then secondly, a couple things that we're looking at kind of going forward that I thought might be interesting. So number one, operations needs to drive your technology. I can't say this enough, and I'll give you a couple examples. One, if you're gonna invest in technology, you need to actually have a cost benefit from it that helps your operations, and it needs to come from your field and your project management teams. They'll tell you what it is they need if you listen to them. And the flip side of it, if you invest in a technology and you think it's great, but your field is telling you it's not great, guess what? It's not great. Okay? It's just not great, because what happens is if they're not going to adopt it and use it, in the US, like we talk about different ways of getting the word around, all it takes is one pipe fitter to know something and they all know it. Okay? So if there's one guy that doesn't like your new time card application, guess what? They're all not going to like your time card application pretty quick. And that's an exact example we have. When we implemented our new ERP, we hired them to design for us a new time card application because we wanted it all automated. We spent $25,000 on it. We were really proud of it. And the guys in our fab shops hated it. They wouldn't use it. It took them too long. If there was one limiting factor on our time cards, it was our fabrication shops. We had more people, more different work breakdown structures in smaller amounts of time, so the number of entries is significantly long. They were the acid test for our time cards. So we finally stepped back. Our technology consultants were telling us, well, I can make this change and this change and this change, and they're all little bitty changes that make it a little bit better. And we said, stop making it a little bit better, start over, it's not working. And we threw it out, and we started over and spent another $25,000, and we got a result that actually works. And the minute that we implemented it and the complaints stopped, we knew we had something. So I would tell you, just listen to your people. Your operations need to drive the technology. Number two, don't take for granted anything related to your infrastructure. I've been absolutely shocked and surprised at things I thought we were doing to only find out that we weren't doing them. So about 3 years ago, we hired Hewlett-Packard, HP, to come in and do a full audit and be a consultant to us in a number of different ways. And HP found out that we were backing up half of what we thought we were backing up, which was shocking to me, because if we had had a fire, we'd have lost half of all of our data and information, which could have been devastating. So just don't take for granted things related to infrastructure. If you're not certain where you're at, then go hire somebody that can tell you where you're at. Third thing is form a steering committee when you're making decisions. In my 20 years involved in helping make those decisions in our company, I would tell you we've made a lot of mistakes. I've made a lot of mistakes. For one, never have just a technology professional make a decision on behalf of the company to implement things. You need all your stakeholders involved. It can't even just be your technology leader and the CEO or president making a decision. That's a bad idea. You need to have a team that represents the field operations, the project managers, the estimators, and they all need to have a stake and a say because they have to buy in. And third, one thing we found in the last year, the more you standardize, the more you drive money out of that technology spending. And this is surprising how big this issue is. So once we started gathering data on how much we were spending on technology, we could really get our hands around, well, what's impacting that spending? Every time somebody in our company has a need for technical support, we have a help desk. You have to fill out a ticket. You categorize it. It gets worked on quickly. There's a way that we deal with that. But what it's allowed us to do is start to see where we're spending our money. And simple things like standardizing on the phones that you use is a really big deal. We've got 500 phones in our company. And if you've got 25 different phones in the company that you're supporting, your cost to support those is going to be exponentially larger than if you have 2 or 3 kinds. Same thing goes with computer hardware and the software that you run. So some people aren't going to like it. That's the way it is. Okay, we don't allow people to bring their own technology to the company. We're going to give it to them because we want to support it. We know that the cheapest way to support it is to standardize on things. Okay, so I'm going to talk for just a real quick minute on 3 things that we think are really coming that are trends moving forward. I talked about manufacturing in the past, and we have a goal. And I'm going to put this up here. I know it's hard to read. I'm not asking you to read it, but I'll describe it to you in just a minute. We call this goal 2080 to 80-20. Right now, what's paradigm in the industry is 20% of the work gets done in a fab shop and 80% gets done in the field. And we honestly believe we can flip that 180 degrees and do 80% in a manufacturing facility and 20% in the field. And the way that you achieve that is by planning it from the very first day. And if you're waiting until you're long into the project to figure out what you're going to manufacture, you're way too late to really take advantage of it. So what I put up here is an example of how we start to plan projects. This is a brewery project where our role on the project is to provide steam boiler system, glycol chiller system, compressed air system, and carbon dioxide system for a craft brewery in Charleston, South Carolina. And it's in schematic design, and I can already tell you, we think we can do it in 22 pieces, the whole thing. So the entire job will be delivered in 22 pieces, and we think we're going to be on site for 3 weeks, totally. Okay, so you start planning this out at the very beginning, and the importance of that is this right here. We can actually tell you, these are piping sections. They're bridges that have as many as 40 different pieces of pipe on them for different services. And those racks will come out 40-foot long pieces, about 8 foot wide and 6 foot high with 3 levels of piping. And those racks also have ability to add cable tray and conduit and lights and different things. And the utilities exist down here. My point in showing this is that we actually had to have the architect change the building design to accommodate this approach. So if you wait until the building is designed and now you're involved trying to figure out how much you're going to fabricate, you aren't going to take advantage of it to the greatest extent. And when we started talking about the benefit of doing this, well, the benefit is they're going to start brewing beer faster if we can help them do this. Okay, the owner understands that. And so all of a sudden, it's a priority on the job for us to be able to get in 40-foot long piping bridges, where it wasn't before. So my encouragement here to you is to really plan that from day one and start talking to people about it. Second thing that I'm going to talk about is a technology called EVDI. And do people in here use remote desktop at all? Is there people that understand remote desktop? So What remote desktop allows you to do is to, probably if you use it, you dial in to the server from distance, and you can run some very simple applications. So what this chart represents, as I go to the right, is more and more complicated, graphically driven softwares, okay? And over on the left are things like very simple things, Word and Excel and Outlook and so forth, but there's this big gap right here, right? You can't run CAD files, BIM models, from remote desktop because it doesn't have the graphics power. Well, guess what? There is a software solution for that, and it's called EVDI, and EVDI exists right here. And it was developed very specifically for global corporations that wanted to collaborate on models from around the world. So if you can think of auto manufacturers and oil and gas companies that have people disaggregated around the world and they want to collaborate on one model, and those models are very complicated, this technology was designed and built for that. So the way this works is you have a very robust server on the back end, and all of your users would connect into that. Why is that interesting to our industry? Okay, how much do you spend on your BIM machines? We spend about $4,000 to $5,000 on a computer for being used for BIM in the US. Okay, I said we had 250 computers before. With this approach, I need Chromebooks in everybody's hands. They cost $250 and they have no software loaded on them. None. They have, I take that back. They have one piece of software that has to be loaded on it, and it's an application. It takes 5 minutes to download and install. It's the Citrix EVDI app. And once I install that, I have everything I want to run available to me from the server. So when we're in the middle of investigating this right now, we believe it's a 3-year payback for our company. It's a large investment. It's about $360,000 to implement this. But it pays back in 3 years. And the thought of having the ability to have people work anywhere with as simple as a Chromebook, and you break it, we just hand you another one off the shelf and away you go. And I can have others collaborate on our models anywhere in the world without them having to have our database and so forth on their computer is a really big deal. So to us, this looks like a really good opportunity, and I'm eager to see where our research lands. The third piece of technology I want to show you real quick is a clip, and it relates to the service side of our business. So I know I've kind of run past, but I'll try to get through this real quickly. If you have a service organization, you have service technicians that are out there solving owners' problems. The most experienced guys are some of the smartest guys in our whole industry. And in our company, one of our best, his name is Daryl. Okay, and Daryl can solve any owner's mechanical problems, literally. He is that good. And as a business owner, if there's any way I could ever leverage Daryl across 5 or 10 times as many owners, I would be very interested in that. And I think the owners would too. So we've been talking about, well, how do I create a virtual Daryl environment? Okay, and we actually started to find there is some technology that would allow us to do this. And there's a company in Nashville, Tennessee, one of our competitors, that's implemented this with a software company already. And what I've got is a clip from the software company of what this looks like. So I'm going to play that real quickly here.
On-site techs are equipped with safety-certified smart glasses or other mobile devices. The equipment is powered by Vision, our cloud-hosted software platform that allows real-time audio and visual communication, adding visual intelligence to every platform you currently use. Here's how it's being used today. Your tech arrives at the site and he is immediately able to capture video and photos of equipment and site conditions and load those to service tickets or their customer portal. Vision then empowers him to live stream with senior techs for interactive expert analysis and input to make sure the job is done right the first time, reducing callbacks. It then streamlines the process of documenting the work performed by helping create detailed service reports for greater transparency, accountability, and speedy customer decision-making. Plus, Vision provides a powerful platform for training, since techs can easily create and save video assets at any time, adding to a shared knowledge base accessible by anyone on your team.
So imagine, if you will, Daryl sitting in front of 5 or 6 monitors and multiple technicians out in the field working his eyes and ears and hands. And there's just tremendous benefits potentially to this, because now I can have Daryl's knowledge on multiple job sites at one time, leveraging that for many customers. And by the way, as Daryl is talking through the technician on how to solve that problem, that technician is learning from the smartest guy we have. So there's a number of benefits that happen from it. We have the glasses in our office. I would tell you they're very disorienting to put on. I've had them on and played with them a little bit. It does give me a little bit of cause for concern from the safety side. I don't think our industry has solved that maybe yet, or how we deal with that, because certainly don't want a service tech with glasses on and the computer screen up on one side working around live equipment. That could be very dangerous. But the concept is valid and it's very interesting, and I think there's real merit to it. To me, you have to pay attention to what's going on out in the market, and this is a competitor of ours that has implemented this successfully, and it's something we're very interested in. So that concludes what I had to present today, and at this point I'm open for comments and questions. Yeah.
Just going.
Just on the work-life structures, when you talk about disciplines, do you use that for project management, engineering,
Yes.
staff?
Yes. Yes, we do. So that work breakdown structure has to handle not just labor, but it's got to handle anything that has cost on the job. So there's also categories for material, equipment, subs, and miscellaneous. But yes, we categorize all of those as well. Yes.
2 points. Have you found your BIM integration into the SharePoint system to get your project engineers to manually update that data into the SharePoint?
Yeah, so what happens is the project engineers update the status, and then we actually have the model connected directly to a database, and that database is going and getting the data from the model every hour.
So the SharePoint and BIM data is connected.
Correct.
And have you had any experience with any head contractors using the SharePoint system, connecting your BIM data to that SharePoint?
Not yet, no. Actually, we sat down with some of the head contractors to show them what we're doing with Game Changer, and we haven't found one yet that's figured out how to do the same thing on the GC side. So when we talk to them about embedding labor into the model objects, we haven't found a general contractor yet that's doing it.
Yeah. Just EVDI. What does that actually stand for?
It's Engineering Virtual Desktop Infrastructure.
Right, and the other one was with SharePoint. You said that you actually employ people to just develop your categories in SharePoint. So how much time do you think that you devote to that?
So we actually use another software on top of SharePoint that makes SharePoint easier to program.
Yep.
And that's called Nintex. And Nintex, I know, has large support here in Australia.
Yep.
And I would tell you, one individual in 6 months would have you a lot of things completed and organized and set up.
Right, okay. And what was that called again, sorry?
Nintex.
Nintex.
Nintex.